Today we will be learning about Lagrange method in this video. This method we use it to find maxima or minima of given function which will be having more than two variables. जब हमने मैक्सिमा मिनिमा पढ़ा था वहाँ पे सिर्फ टू वेरिएबल्स का फंक्शन डिस्कस किया था, जिसमें दो से ज़्यादा वेरिएबल है उसका हमने नहीं पढ़ा था. So now this specifically this method, Lagrange method, we use it to find the maxima minima for the function which are having more than two variables. मतलब यहाँ पे अगर x, y, z, f will be given in the form of three variables or maybe more than that. So but there here one thing is extra is since there are more than two variables are there will be some relation given between them, like how they are connected with each other, like x square plus y square plus z, something like that. Like what is the relationship between these functions, these variables. So that is nothing, one extra part which is added over here. So that function we will be calling as here as a constraint function. This is the extra part which was not there when we studied about the two variables. So let's take one example so we will understand how we will solve it. So before that I will go through the steps which we will be following. Like for example here, if the given function is x, y and z variables which is involved in that, then let's say that this function, like as I said before, there should be some relationship given between these variables x, y, z, how they are related with each other, and we will call them as a constraint function. Okay, that how we will denote this constraint function by using phi of x, y, z. So in the step 1 we will be using first of all we will identify what is objective function and what is constraint function. ऑब्जेक्टिव फंक्शन क्या होता है, जिसका हमें मैक्सिमा या तो मिनिमा जिसका भी निकालना है, जिस फंक्शन का हमें निकालना है वो फंक्शन हमें बन जाता है ऑब्जेक्टिव फंक्शन. एंड द नेक्स्ट थिंग इज कंस्ट्रेंट फंक्शन. वो तो हमने अभी डिस्कस किया था कि जिसमें रिलेशनशिप दिया हुआ है थ्री वेरिएबल्स का, हाउ दे आर रिलेटेड विथ ईच अदर, that function will become as a constraint function. So that we will denote by phi of x, y, z. Now Lagrangian function or auxiliary function, how we will write it is, we always write it with capital F of x, y, z, which will give which is nothing but the addition of our objective function and constraint function. Along with this, one lambda is there here, we call it lambda in maths, but here we use it as a Lagrangian multiplier. That's one extra part which is added over here. We will call it this as equation 1 because we will be using this for further simplification. So now next thing is, जैसे हमने मैक्सिमा मिनिमा जब भी हमने पढ़ा है तब हमने हर बार देखा है कि गिवन फंक्शन का हम डिफरेंशिएट करते हैं. यहाँ पे भी सेम थिंग होगा. Given function is in only differentiate here is the three variables are there x, y and z. तो हम तीन बार partially differentiation करेंगे इसका with respect to x, with respect to y and with respect to z. The concept is same here, only one additional variable is there z, so one extra partial derivative will be extra here, so which is here del f by del z. Now again what we have to do it. After this we used to do it like we were to find the stationary point. जो स्टेप हमने वहाँ पे भी की थी यहाँ पे भी हमें करनी है. स्टेशनरी पॉइंट आपको याद होगा हमने कैसे निकाला था. जो भी डिफरेंशिएशन किए हैं डेल एफ बाय डेल एक्स, डेल एफ बाय डेल वाई, वो हमने इक्वेट किए थे ज़ीरो के साथ. यहाँ पे भी इसको करना है, इक्वेट करना है ज़ीरो के साथ टू फाइंड द स्टेशनरी पॉइंट. लेकिन यहाँ पे एक एक्स्ट्रा स्टेप जो है, ये स्टेशनरी पॉइंट्स को हमें वी हैव टू सॉल्व इट अलॉन्ग विद द कंस्ट्रेंट फंक्शन. सो ये जो स्टेप है वो एडिशनल स्टेप है. वी हैव टू सॉल्व दिस वट एवर स्टेशनरी पॉइंट वी गेट इट, बेसिकली दोज वैल्यू वी हैव टू सब्स्टिट्यूट इन द फंक्शन ऑफ कंस्ट्रेंट फंक्शन. सो दैट्स हाउ वी विल गेट इट stationary point. Then now next step will be, after getting the stationary point we have to decide वो मैक्सिमा है या मिनिमा है, वो डिसाइड करना है by using that RT minus a square जो हमने लास्ट टाइम भी देखा. Let's take a small break over here. Meantime, you can revise the concept. In the next video, we will be discussing this more in detail.